limits of trig functions. The big thing you're going to need to remember out of here is the kahuna. Indeed. Remember the big kahuna? Yeah, you might want to write it down. Cosine squared theta plus sine squared theta equals 1. Aha. We have already looked at how to evaluate limits of trig functions by direct substitution, provided the function is defined and continuous at theta. So let's find these limits. Now remember, be careful on how you write. This is going to be the sine of 3 times 2 pi over 3 divided by 3 times 2 pi over 3. Now obviously we're not going to get 0 in the denominator, so that's a good thing. Our numerator is sine of what? Sine of 2 pi divided by 2 pi. What is the sine of 2 pi? 0 divided by 2 pi is 0. So that limit does exist. That limit is 0. Let's go to the second one. Now remember, this notation means 2 times the cosine of theta squared. Notice all I did was a rewrite, so I still have to write limit. Please notice the equal sign is not between the limit and the 2. The limit, see where the equal sign is. Now we'll do direct substitution. 2 times the cosine of pi squared. What's that give us? What's the cosine of pi? What's the cosine of pi? -1 squared times 2. Direct substitution on trig functions is not a problem. We got 0 over 2 pi, which was 0. Each of the functions above was defined at the value that theta was approaching. However, we have seen that even in the algebraic world, not all functions are defined at a value, but their limits do exist. So there could be a hole, but still have a limit. The same is true in the trig world. Let's consider for a moment the limit below. Try to evaluate this by direct substitution. All right, so let's try. We get 1 minus the cosine 0, 0, not theta, over the sine of 0 squared. What's the cosine of 0? 1. 1 minus 1. What's the sine of 0? Squared is up. That's called indeterminate form. Have I told you that word? That's called indeterminate form. Indeterminate form does not mean that the limit doesn't exist. It means you got to try something different. Indeed. So, in this case, we can often rewrite the functions in terms of a single trig ratio using identities, meaning the kahuna family, if we've got a squared trig function. So, let's rewrite this thing. Notice in the numerator, I just have cosine theta, 1 minus cosine theta. The cosine theta is not squared. I cannot do anything to it. But I can rewrite sine squared theta based on the big kahuna. What's another way I could write sine squared theta? 1 minus cosine squared theta. Good. So that numerator and then the denominator Now, if you'll notice, we've got everything written in terms of one trig function. We've just got cosine. You say, well, that doesn't help me anyway, so what am I going to do? The denominator. What do you see? Because the denominator is called a what? It's a difference of two squares. That denominator is a difference of two squares. That's right. So I'm going to write the limit as theta approaches 0 of 1 minus cosine theta over 1 minus cosine theta times 1 plus cosine theta. You stop me if there's something you do not understand. Now we see, woohoo! What's left in the numerator? 1. Now I'm going to do direct substitution, so I will not write limit down again.
But if we want to get it.
I'm sorry?
But if we'd like, we
Yes. Now, Abby, if you wanted, you could rewrite this as the limit as theta approaches 0 of 1 over 1 plus cosine theta. Is that what you're asking? You don't have to write this step down. You could go straight from this red to direct substitution if you wanted to. So we'll direct substitute now. And remember, direct substitute, I do not write down limit because I'm actually taking the limit. 1 over 1 plus, what's the cosine of 0? So, what's my limit? My limit is a half. What? Did you want it to be a weirder number? Did you want it to be a weirder number?
like 1/2 of
What's the matter?
cosine of. Okay. So
Maggie Matthew,
Maggie.
cosine of 0.
Okay, so
Next page. Find each of the following limits by rewriting the function in a form that is defined for the approached value of theta. Here's the deal. Every one of those, if you plug in that value of theta that you're taking the limit as x approaches or theta approaches, you're going to get a bad thing. You can get a bad thing. Let's just look at this one. This would be 3 times the tangent of 3 pi over 2 times the cosine of 3 pi over 2. Let's talk about 3 pi over 2. Remember 3 pi over 2? Right there. What's the tangent of 3 pi over 2?
something over 0.
Sine over cosine, something over 0. Tangent's negative 1 over 0. Sine of 3 pi over 2 is negative 1. Cosine of 3 pi over 2 is 0. Tangent to 3 pi over 2 is undefined. I cannot do this problem by direct substitution. It doesn't mean I have a hole necessarily if I graphed it, but I got a problem. Yep. Tangent of 3 pi over 2 is the sine of 3 pi over 2 divided by the cosine of 3 pi over 2. The sine of 3 pi over 2 is negative 1. The cosine of 3 pi over 2 is 0, undefined. Okay. So we got to try something different. Well, to try something different is that stuff that you did in pre-cal. We don't have any squared trig functions, so that we cannot use the Kahuna family, but we can rewrite. But I don't see a cosine I can cancel. Okay, so this is the limit as theta approaches 3 pi over 2 of the sine of theta over cosine theta times cosine theta. That's exactly right. So, number 2. If you try direct substitution, it's not going to work. So we say, well, okay, fine. What else could I do? What's secant? Aha, secant is 1 over cosine, so this is the limit as theta approaches pi over 2 of 1 over cosine theta times cosine theta divided by 4 theta. What's my numerator? 1 over 4 times 2. Jiminy Christmas. Come on, student. Sorry, Nikita. Pi over 2. So that's 1 over 2 pi. Your limit is 1 over 2 pi. Do you have questions yet? Nap. No. Number 3. What could we do? Change the answer to what? So this is the limit as theta approaches pi of cosine theta times sine theta, excuse me, over cosine theta, all divided by sine theta. So this is the limit as theta approaches pi of 1. That's right, that's a constant. Now, if you'll notice in your notes, there are several tables. We are not going to do all 3 of those tables, but we are going to do this first one, and you will need your calculator here. It is important to note, please, please, please come up with a highlighter. Come on. I don't know what's going on. I just don't know. In all cases of evaluating limits, direct substitution should be tried first. If that does not yield a value, then a simplification can be tried. You always try direct substitution first. Occasionally, it is not even possible to rewrite the function so it's undefined. I don't know why. I think this author's I think he got screwed up here a little bit. There are 2 special trig limits that can often be employed. I want you to look at this. We're going to spend some amount of time on that little limit right there. Now, what I want you to do is go to your calculator. I want you to be in radian mode. We're going to graph that thing. Oh, come on. Okay, Nikita, I'm going to turn this off till I can get things working. Okay, I got it. Sine theta over theta. Remember, you're just going to use x instead of theta. Are you all in radian mode? Go to your window. Notice this is a limit. Well, what we're going to do, if you look at the very bottom of the page, it says the limit as theta approaches 0. So what we're going to do, we're going to go, our x min is going to be negative pi over 2. And our x max is going to be pi over 2. Our x scale is going to be pi over 6. So negative pi over 2 to pi over 2 and pi over 6. How would you know to do that? I'm trying to teach you. And I don't mean to be obnoxious, but you wouldn't have.
Okay. Wait, Miss Bennett, it's not.
Your y values, make them go negative 2 to 2. You all right, Wendy? The reason I chose what I chose is the limit. I'm trying to take the limit as theta approaches 0, if you look at the bottom of the page. So what I'm doing is I'm picking x values that are close to 0 on either side. I just picked pi over 2. I could have picked pi. I could have picked pi over 4. I just picked pi over 2. Now, I want you to graph it.
I just realized.
We got to go fast because we've got to get this done. I want you to go to Format, which is second zoom. Now yours is going to look a little different than mine. But what I want you to do on yours, I want you to go down to where it says Axes On. And I want you to turn yours off. Indeed, your axes are gone. I'm just going to make mine. Yeah. And then graph.
That whole.
You see a hole. Do you see a hole? Go back and turn your axes back on. Now, on your notes, I want you to notice, here's what it's asking you to do. It's asking you to do, find the y value when x is each one of these. Now, bless you, we don't have time to find them all, but I want you to find at least a few of them. So go to your calculator. Probably the quickest way to do it is to go to Second Calc. Snap. Second, the other second. Option 1, we're going to do value. Now, the one on the farthest to the left is negative 0.01. Type that in. I want you to write that number here. Oh, not there. Yeah. How many 9s were there?
4.
1, 2, 3, 4, and then 8, 3 or something? Now, so you know where I'm going to get the numbers. The next one, if you do that one, it's going to have 1, 2, 3, 4, 5. It's going to have 6 9s, followed by an 8. The next one has 8 9s, followed by an 8. Now, if you'll notice, this number and this number, based on what the graph looked like, what do you think the y value is for this one? It's this one. That number goes right here. This number goes right here. And this number goes right here. Now I want you to look at this question. What is the limit of sine theta over theta as theta approaches 0 from the left? Now, where is 0? I do not see a theta equals 0. It's right there, isn't it? As theta approaches 0 from the left, what do those numbers get closer and closer to? 1. As theta approaches 0 from the right, those y values get closer and closer to 1. Now, I want you to take a look right here. What has to be true for the limit as theta approaches 0 to exist? What has to be true? The left and right hand limits must be the same, are they? That limit is 1. Ladies and gentlemen, we could not have simplified sine theta over theta. There was nothing we could do. This is one you have to know. Know this one. It will come up frequently. You know the limit of sine theta over theta as theta approaches 0 is 1. Now, again, go to the next page. For time's sake, I'm going to put in, here's the deal. If you are trying to find this, and look here. See how we're trying to find the limit as theta approaches 0? You may not believe this, and if you don't, you get your calculator out on your own time and figure it out. But the numbers that go in that table are the same as the numbers here. They are the same. And you can, again, you can go do that and figure it out, but we are going to run out of time.
The 993.
Those 0.99s, yeah, the 0.99s. So if the numbers here are the same as in the other table, so what is the limit of this function as theta approaches 0 from the left? 1. As theta approaches 0 from the right? 1. And as theta approaches 0, period? 1. Based on what you have just observed, what inference can you make about the value of the limit of sine of c theta over c theta when theta approaches 0, where c is any constant?
The limit?
That limit is 1. It is 1. Go back to your calculator. Go into y equals, and I want you to graph this. So we put it in, 1 minus cosine theta over theta, but we had to use x instead of theta. Go back and turn off your axes. So go to second format, turn them off.
You know, I kind of called it that.
Oh my gosh, there is a hole. There is a hole. So, ladies and gentlemen, at what y value is that hole?
Zero.
So, I want you to take a look at this. What is the limit of that function as x or theta approaches 0? 0. From the left, it's, oh, come on, student. From the left, the limit is 0. From the right, the limit is 0. Because the one-sided limits are equal, the limit is 0. I will have these filled in notes posted if you want to go back and look at those tables any. Do you have questions, though? This is the other one that you have to know. Know this one. You have 2 limits that you just flat out have to know, and this is the second one. 2. The other one is the one we just did. The limit of sine theta over theta as theta approaches 0 is 1. And this one. Now, what we have left is just practice, okay? We will do, shoot, we're good. Okay. You go back to the first page of your notes. at the very top. No. Well, where the Jimmy Christmas? I used a highlighter. Whoop. Second page. It was right here where I highlighted. In all cases of evaluating limits, direct substitution should be tried first. If that doesn't work, you'd try something else. Number 1, direct substitution, e to the 0 times the cosine of 0 over 4. What's e to the 0? 1. What's the cosine of 0? 1. So what's my limit? Limit's 1/4. Next one, direct substitution. Think it, because it ain't going to work. In fact, I have 0 in the numerator and the denominator, don't I? I'm sorry? Here's what we know. The limit of c times theta over, what am I doing? The limit of sine of c theta over c theta as theta approaches 0 is 1. There's no, what am I missing? So tell me what I need where. I need a 4 in that denominator, don't I? Now listen, you can never, ever rewrite sine of 4 theta as 4 sine theta. They are not the same thing. But here's what I can do. I can take any fraction or any number in the whole world. What number can I multiply it by so the number doesn't change? 1. I can multiply by 1. I need a 4 right there, don't I? That 4's in the denominator, isn't it? So really, I just put a 1/4 in there. Limit. I'll write it bigger. This says sine of 4 theta over theta. I need it to say sine of 4 theta over 4 theta. But look what I did. I just multiplied this by 1/4 because that 4 is in the denominator. I can't just multiply by a 4th. I can only multiply by 1. I offset multiplying a 4 by a 4th with multiplying by. What do you multiply a 4th by to get 1? So watch this. I just multiplied that limit by 1. Question? Remember, I could put the 4 inside right here, but then I could pull it out anyway. I'm putting 4 in the numerator and the denominator is what I'm doing. Okay, Emily, it's all right. I'm doing this. I'm multiplying top and bottom by 4, which means I'm multiplying by 1. But that 4, I don't really want it to be there.
Teachers, please pardon the interruption. At this time,
Look at this.
any freshman, sophomore, or junior.
What is the limit
athletic
of sine
or
4 theta over 4 theta as theta approaches
has not had their picture
as theta approaches theta, as theta approaches 0?
theater at this time. Thank you. Any student,
Look right here.
freshman through junior.
That
who has not
answer
had
the
their
question I was asking.
picture, they have athletics or
Here we go. Nikita, I may have just left out a piece, and if I did, I'm really sorry. Number 4. I've got a sine 5 theta on the top. What does the bottom need to be? The bottom needs to be a 5 theta. Now, I don't want that 2 and I don't want that 3. So I can take out a 2/3. I'm going to do it this way because it's easier for my brain. I'm going to pull out that 2/3. Now you see I can pull out that 2 because it's a coefficient. And I can pull out that 3 because it's a coefficient. I cannot pull out that 5 because that's inside the trig function. So what do I need? I need a 5 in that denominator, which means I need a 5 in the numerator. But I'm going to pull it out. So I've got 10/3. Please do not say that that's 10 over 15. Oh, what's that limit? 1. So it's 10/3 times 1, which is 10/3. Question? I want to see this step right here. Yeah, oh, stop it. I want to see that step. The tangent of 0 is the sine of 0 over the cosine of 0. So that's 0 over 0. I get indeterminate form on this one, which means I got to change something. Limit as theta approaches 0 of sine theta over cosine theta. Dividing by theta is the same as multiplying by now you say, well, that didn't do me a confound bit of good. I promise it did. Let me show you something. Don't write this down. What do you get there? 8/15. What do you get there? What did I do? I just switched the denominators. Notice that I'm taking the limit of a product. One of your properties said that if you take the limit of a product, you take the limit of each one separately and then multiply them back together. What is the limit as theta approaches 0 of sine theta over theta? 1 times. What is the limit as theta approaches 0 of 1 over cosine theta? Because the cosine of 0 is 1. Is this the last page? Oh, you're good. Life's good. Four questions. Whatever we can't get through, I will post. And you can work through them. Number 6. I really want to get, oh, where you go? Oh boy. Okay. Number 6. Time. So we're just going to have to go. I'm going to factor a 2 out of that numerator. What can I do with that 2? So this is 2 times the limit as theta approaches 0. 1 minus cosine squared theta. What else? It is sine squared theta, but it's a difference of 2 squares, isn't it? So this is 1 minus cosine theta times 1 minus plus cosine theta over theta. But Ms. Dennett, how did you know not to use sine squared theta? Because that wouldn't help me. It wouldn't get me anywhere. Four times 3 divided by 2. What is that? That's 6. What's 4 halves times 3 halves? Oh, wait, hold it. No, that's not right. What's 4 halves times 3? 6. Now, I want you to notice. I split the 4 into 3, and I made the 2 be 2 times 1. You're staring. I don't know if that's bad or... So I'm going to do this. I know this one, don't I? The limit of 1 minus cosine theta over theta as theta approaches 0 is 0. So this gives me 2 times 0 times, I don't care what that last one is because I've got a 0. I'm sorry we're having to go so fast here. Look at this one. Don't write this down. 1 plus 4 plus 5 over 3. What do you get? 10 thirds. What if I do 1 plus 4 over 3 plus 5 over 3? Do I still get 10 thirds? I do. Notice single term in the denominator and the numerator is pluses and minuses. I can break it apart, and that's what I'm going to do here. The limit as theta approaches 0 of 1 minus cosine theta over theta plus sine 2 theta over theta. I'm taking the limit of a sum, so I can take the limit of each one separately and then add them back together. What is the limit as theta approaches 0 of 1 minus cosine theta over theta? That's 0 plus the limit of sine of 2 theta over theta as theta approaches 0. What do you see there? I need a 2, which means I need a 2 in the numerator, which means it's coming out. So this is 0 plus 2 times, what's the limit of sine 2 theta over 2 theta as theta approaches 0? I don't have time to do the last two. Please, please, please look at them on your notes.